This video was made possible by Hover. Get 10% off your first custom domain or email by going to hover.com/Wendover. The South Pole is, without a doubt, one of the most extreme places on Earth that's continuously inhabited by humans. In fact, it's safe to say that there's nowhere on Earth with such a large population, about 45 in the winter and 150 in the summer, where nature is so constantly working to kill you. The warmest it's ever been at the pole in recorded history is just 10 degrees Fahrenheit or -12 degrees Celsius, a temperature that most of the world would consider absolutely unbearable, while most of the year is spent at 50 or 60 below zero. But it's not just temperature that gives the pole its extreme classification. It's also one of the driest places on Earth, with a relative humidity regularly dipping to 0.03%. In comparison, most places' humidity hovers between 55 and 75%, meaning that those at the South Pole are constantly battling skin and body dehydration. In addition to all that, due to the thousands of feet of ice and snow layered on top of the ground below, the pole is located at around 9,300 feet or 2,800 meters above sea level, which for most people isn't high enough to be deadly, but is enough to potentially lead to sickness, which could elevate the severity of other conditions. Put together, these factors compound to paint a pretty clear picture. The South Pole was not made for humans, but nonetheless, through sheer force of will, we're there permanently. What makes this possible is the Amundsen Scott South Pole Station. This American-run facility is now in its third iteration. The first was built in 1956 as a simple wooden prefabricated structure that quickly became buried by snow. This was upgraded in 1974 to a larger geodesic dome that itself protected buildings inside, and this too was buried by snow each winter, meaning that each summer, considerable time and fuel had to be used to dig the station out. In a place where absolutely everything has to be flown in, this was an enormous expense that got in the way of the science. Therefore, in the years leading up to the turn of the millennia, the United States Antarctic Program worked to develop a more permanent solution. And that solution was this. Now, this current structure is undoubtedly distinctive, but its design comes with good reason. The building itself is shaped like an airplane wing, with a leading edge facing the prevailing winds. This pushes air down, accelerating it underneath the facility, which naturally clears out the snow. As most of Antarctica is a desert, only about 8 inches or 20 centimeters of snow per year accumulates at the South Pole, but as the temperature quite literally never goes above freezing, the snow never melts. In addition, since the landscape surrounding the pole is quite flat and the winds are strong, enormous snowbanks quickly form on the upwind side of any building. While the shape of the main station building reduces this, snow still does accumulate in front and under it. Therefore, it's designed so that, every 10 to 15 years, the structure will be raised up a few feet. This is a 30-day process, which can only happen over the 3-month summer period when the station can be reached by plane, meaning that in order to not shut down the facility during its busiest period, the building was designed to be operational while it's lifted. Therefore, its different components are connected by a number of flexible joints that can move during the lifting process. Of course, the actual purpose of the station is for research, but that poses the question, what sort of research do you actually need to be at the South Pole for? Well, as it turns out, quite a lot. One of the top uses is for astronomy. You see, in most places, water vapor in the air ever so slightly distorts the image from telescopes, which for most types of astronomy isn't a problem, but when one is trying to observe galaxies billions of light years away, for example, precision is key. In fact, the South Pole Telescope itself has discovered truly countless far-away galaxies. In addition, thanks to this clarity, it was a crucial component of the planet-wide network of telescopes that created the first ever direct image of a black hole in 2019. Beyond that, the clean air of the pole allows for super precise atmospheric research, and the relatively low annual accumulation allows for climate research through studying ice cores. This is all to say, the South Pole Station isn't just there for prestige. It's a critical piece of scientific infrastructure supporting a huge variety of research. However, most of the research itself isn't actually conducted there. Given how expensive it is to travel to the pole, various institutions generally only send a small number of people to the station to calibrate and maintain their scientific equipment, while the data are sent back to their respective headquarters for analysis. That means that, each summer, in that 3-month window when flights can land, there's a flurry of activity as personnel try to get all their work done before the season is over. Then, over winter, only a skeleton crew remains to keep everything running. Of course, given the absolute isolation that occurs over this period, the station staff is very carefully selected. Everyone is screened to assure that they're in near-perfect physical health, as conditions that might be minor in the rest of the world can turn deadly given the station's lack of advanced medical care, and they're also subject to extensive psychological evaluation. This is primarily to assure that they can handle the severe degree of isolation, 6 months of continuous darkness, and small work community for 9 months, as, if mental health deteriorates over winter, there's truly no way out. Over this period, there tends to only be a single doctor at the station conducting their work with somewhat limited medical facilities. This doctor is subject to even more rigorous medical screening themselves, given their importance to the health of everyone else at the facility. In fact, some countries' Antarctic programs even require their doctors to have their appendix removed to prevent the possibility of appendicitis. Of course, a single doctor can't know everything, so for any advanced conditions that arise with station staff, the facility is outfitted with advanced telemedicine equipment which can transmit medical data in real time, so specialists in the US can attempt to diagnose and treat a patient remotely. Of course, in order to do that, they need internet, which is yet another challenge at the South Pole. Most non-polar isolated research stations now are able to rely completely on commercial satellite internet providers, but that's not entirely possible at the bottom of the world. Commercial satellite internet is only widespread where there's a market, and there's only a market where there are lots of people. That means that most telecommunications satellites are not positioned in an orbit that the South Pole can reliably view. Therefore, the station has to largely count on the NASA network of communication satellites designed to link spacecraft to Earth. In fact, this network is the very one the International Space Station uses for data up and downlink. Even this system, though, is only in view of the pole a few times per day. On November 13, 2020, for example, the South Pole could connect to one of its satellites from 3:29 to 3:55 p.m., 4:59 to 7:05 p.m., and 8:09 to 9:27 p.m., meaning they only had a connection for 3 hours and 50 minutes that day. These NASA satellites provide the bulk of the station's data connection, with an overall capacity of 275 megabits per second, meaning they use these short passes to transmit the bulk of the scientific data back to the outside world, and this is also the time when it's possible for the station staff to use the internet themselves to connect with their families or friends. The station supplements this connection, though, with a daily 4.5-hour pass by a UK Ministry of Defence communication satellite, which provides a much leaner 1.54 megabits per second data link, and a subsequent 4-hour pass by a US military communication satellite, which allows for 10 megabits per second of uplink and 30 megabits per second of downlink. For the rest of the day, the station only has a very rudimentary 38 kilobits per second data link through the Iridium satellite network, meaning for all but the most urgent communications, it's cut off from the world. Beyond that, even just taking out the trash is difficult at the South Pole. The station is required by international law to limit waste as much as possible, and this means that nearly everything brought in is eventually brought out. All trash and recycling is collected during the winter season and flown back to the much larger McMurdo station. There, recycling is processed while trash is grouped together and stored to be sent all the way back to the US on the single annual resupply ship. That means that any garbage will travel 8,000 miles or 13,000 kilometers over a period of up to a year from a trash can at the South Pole station to a landfill in the US in order to be disposed of. The reason for this obsessiveness around cleanliness goes beyond environmental consciousness. It's crucial to the science conducted there. For example, there's a zone that stretches 98 miles or 150 kilometers northwest of the station where no motor vehicles at all are allowed. That's because this zone is upwind from the station's atmospheric research station, which is located there due to the pollutant-free air, and the exhaust of one snowmobile could contaminate the air enough to throw off the observations, potentially complicating some research. Now, it's worth pointing out that this structure, the South Pole Station, is the only thing separating the staff of the facility from the deadly Antarctic environment, and for 9 months a year, the facility is entirely unreachable. Outside of the summer season, stretching from November to mid-February, the weather is simply too harsh for planes to land with any degree of safety, so if this facility fails, there is almost zero opportunity for evacuation. To put this into perspective, if the International Space Station fails, for example, astronauts can almost immediately load into the spacecraft they came in and return to Earth. At the South Pole, even if it were life or death, and even if a pilot was willing to put their life on the line to get to the pole, there are stretches of weeks when the weather makes it physically impossible to get a plane on the ground in one piece. However, in very limited circumstances, when it becomes clear that someone has developed a medical condition severe enough that they will not make it till summer, and when there's a flight crew willing to put their lives on the line to save another's, the Antarctic program has authorized attempts at evacuation. This has only happened successfully 3 times. Each of these flights was conducted by extremely experienced pilots from Ken Boruc Air, a Canadian airline accustomed to operating at the poles in small twin-otter aircraft, one of the only types that can withstand the Antarctic winter cold. These aircraft had to be ferried down from Canada and then landed and held short of the continent for a number of days while waiting for a weather window to fly further south to the pole. Once that happened though, they flew the final stretch and landed in darkness, quickly picking up their patient before the aircraft froze, and then flew to South America to reach an advanced hospital. With these evacuations, it took more than a week to actually get an aircraft down to the pole, so if something went catastrophically wrong that made the entire station uninhabitable, like a fire for example, there'd be little chance of getting everyone out in time. That's why there's a smaller, self-sufficient, fireproof wing of the station designated as an emergency lifeboat. This has a kitchen, a small living area, a dedicated generator, a water treatment plant, and is designed to be able to keep the station staff alive through the winter until an evacuation is possible if the rest of the station fails. All in all, the 45 or so people living at the South Pole over the winter have to be, in the most true sense possible, self-sufficient, because there is almost no opportunity for outside help, and that's exactly what makes it so dangerous. This season, though, the potential for danger is escalated. Right now, in November 2020, the South Pole is reconnecting to the world for the first time since February 14th as its summer season gets started. Now, the world has obviously changed a lot between February and November, but Antarctica has pretty much stayed the same. Up until now, COVID was not a threat to the continent since it severed its link to the world before the virus became widespread. Antarctica is currently the only COVID-free continent, and it's crucial it stays that way. In the cramped facilities of the various bases, social distancing is impossible, one case can turn into a major outbreak very quickly, and there's really no ability for the intensive care that severe cases require. If the virus took hold in the Antarctic population, a winter season, with limited possibility for evacuation, could become very difficult or impossible. Therefore, all staff is now intensely tested and quarantined for at least 2 weeks before flying to the continent, and the stations are implementing policies such as mask wearing for the first time as an extra precaution. Also, this season's activities have been scaled back to essentially the bare minimum required to keep the science going, such as crucial maintenance and resupply, and so almost all construction projects have been cancelled. That means that McMurdo Station, for example, will have a peak population of just 450 compared to 1,250 normally. It's tough to understate how tough it is to live year-round at the South Pole, and COVID is making it even more challenging. Life at the bottom of the world is certainly an adventure, but it's one that requires spending the vast majority of the year indoors in a single building with a small number of people. It's undoubtedly a sacrifice. Most of those living and working there don't do so because it's fun, because for the most part, it's not, but rather, they do so because they believe so deeply and fundamentally that the science, even in the face of extreme adversity, is worth it. As Wendover Productions has grown into a more fully fledged business over the years, it's more important than ever that we present ourselves professionally. In my opinion, a crucial component of that is making sure that the email addresses we use to communicate with sponsors, interview subjects, and others are unique and professional, so that's why I use Hover. They helped me find our Wendover.Productions domain, which I purchased for a super reasonable price, then I was able to set up custom email addresses ending in @Wendover.Productions in quite literally 30 seconds. Nowadays, having an email ending in Gmail or Yahoo or iCloud just doesn't cut it. It just looks unprofessional. And through Hover, setting up a custom email at your domain really isn't expensive at all. Hover also lets you buy a custom domain, which you can use for your website, or you can set up to forward to your YouTube channel, your LinkedIn account, your Twitter, really anything. Thanks to their hundreds of domain extensions, you can go way beyond .com or .net and create a super unique domain like Wendover.productions. All in all, if you want a professional, unique email and domain, Hover is the place to get it, and it's worth getting now before it's gone. What's more, by going to hover.com/Wendover, you'll get 10% off your first purchase, and you'll be supporting the channel while you're at it.